Hi everyone, today I'll be presenting the paper MATA, Multi-Agent Framework for Reliable and Flexible Table Question Answering. This paper focuses on a very specific problem in AI, which is how to answer questions correctly when the information is given in a table. At first, this might sound simple, but table question answering is actually quite difficult because different questions require different kinds of reasoning. The main idea of this paper is that instead of relying on just one reasoning method, the system uses multiple reasoning paths together. It combines them in a smart way, checks which answers are more reliable, and tries to reduce unnecessary computation. So, in this presentation, I'll go through the problem, the architecture of the MATA framework, how the different agents work together, and then the main experimental results and takeaways from this paper. This slide explains why the table question answering is still a difficult problem in practice. The first issue is lack of model agnosticism, which means that which what that means is that many existing methods work well only with certain large closed source models like GPT style systems, but they do not generalize well across different model types, especially smaller open source models. The second issue is cost. Some methods improve performance by repeatedly calling large language models many times. This can help accuracy, but it also makes the system expensive and slow. So even if the method works well, it may not be practical. The third issue is that the current systems often do not fully use reasoning diversity. The table question can sometimes be solved using direct text reasoning, sometimes with code and sometimes with SQL style structured queries. But many systems rely too much on just one of these. So the key problem this paper is tackling is how can we build a table QA system that is flexible across models, more reliable in its answers, and also more efficient in how it uses LLM calls. This slide gives the overall idea of MATA. MATA stands for Multi-Agent Framework for Table Question Answering. The important thing here is that it does not use only one agent and only one reasoning method. Instead, it combines multiple specialized agents and a few lightweight helper tools. The three main reasoning paths are chain of thought or COT, which uses natural language reasoning, program of thought or POT, which uses code generation, text to SQL, which converts the question into a text SQL style query over the table. Then on top of these, Marta uses smaller supporting tools such as Scheduler, the Confidence Checker, and the Format Matcher. So in simple words, the big idea is this: instead of forcing one way of thinking for every question, Marta allows different reasoning styles to contribute, and then it uses lightweight components to manage them intelligently. This slide compares MATA with earlier table question answering frameworks. The main point here is that previous systems usually solve only part of the problems. For example, some methods may only use multiple reasoning paths, but they do not optimize the number of LLM calls. Some methods may do not. Some methods may do some verification, but they are not flexible across different kinds of models. Others may evaluate with limited metrics and miss a fuller picture of performance. According to this comparison, MATA is designed to bring several useful properties together in one framework. These include working across different model families, reducing unnecessary expensive calls, using multi stage verification, evaluating using multiple metrics, and combining several reasoning methods. So, this slide is basically saying that MATA is not just another reasoning method, it is meant to be a more complete and balanced framework for reliable table QA. This slide shows the full MATA pipeline from input to final answer. At the beginning, the system takes in a question and a table. Then a scheduler decides which reasoning part it should get priority between POT and text to SQL. At the same time, the COT path runs in parallel. Then the selected reasoning agents generate candidate answers. If the code based answer is SQL based answer has an error, the system can send it through a refinement or debugging loop. After that, the candidate answers are passed to a confidence checker, which estimates whether one of them is reliable enough to accept directly. If the confidence is high, the system can stop there. If the confidence is not enough, the system uses the judge agent, which compares the candidate answers and selects the best one. Finally, the format matcher makes sure that the final output is clean and the correct format. So the pipeline is not just a generate once and stop; it's more like a generate, refine, validate, and then decide. This slide focuses on the scheduler, which is a lightweight but important component. The scheduler's job is to predict which reasoning path is more promising for a given question and table. More specifically, it helps decide whether the system should prioritize POT or text to SQL. It uses simple but useful information from the input, like the shape of the table and the characteristics of the question. Based on that, it estimates which reasoning path has a better chance of producing the correct answer. One of the most useful ideas here is lazy evaluation. Instead of running every possible reasoning path fully every single time, the system first tries the most likely path. If that answer agrees with the COT result, the third part may not be needed at all. So the scheduler improves efficiency by preventing unnecessary extra computation right from the beginning. This slide explains the answer generation stage. The COT agent generates the answer using natural language reasoning. This is useful for questions where plain reasoning works well. Then the POT agent generates Python code to solve the problem. This is especially useful for numerical reasoning, calculations, filtering, and more structured logic. The text to SQL agent converts the questions to a SQL like query over the table. This is powerful when the table can be handled like a structured database. Now, code and SQL generation are powerful, but they can also fail. The generated code might have syntax errors, or the SQL query might be incorrect. So, the framework includes debug agents that try to fix these errors iteratively. The paper also points out that the refinement is more useful for code and SQL than for plain natural language COT. That is why COT is usually run once, while POT and text to SQL can go through a repair loops. So this stage is about generating candidate answers to different reasoning styles and improving them when possible. This slide covers the final decision stage. Once the system has the candidate answers from different reasoning paths, it needs to decide whether one of them can be trusted. That is where the confidence checker comes in. The confidence checker is a small model that looks at the candidate output and gives a confidence score. If one of if one answer is above the threshold which the paper sets at theta equals 0.1, the framework can accept that answer directly. This is important because it allows the system to skip the judge agent in many cases. The judge agent is more expensive, so avoiding it seems saves time and cost. But if the confidence checker is not sure, then the judge agent is used to compare the competing answers and decide which one is best. Finally, the format matcher ensures that the final answer is presented in the expected way. So this stage helps Marta be both accurate and efficient. It does not overuse the most expensive component unless it is really needed. This slide explains how the authors tested the framework. They use two benchmark datasets. The first is penguins in a table, which is a simpler benchmark and is useful for measuring performance on easier or more direct table reasoning tasks. The second is table bench, which is much harder. It includes more complex tables and more domains and more challenging questions. This benchmark is a better test for whether the framework can handle realistic, difficult table QA scenarios. The paper uses three evaluation metrics: exact match, which checks whether the answer exactly correct; fuzzy match, which is more forgiving to slight variations; and token level F1, which means overlap in the answer tokens. This is important because single metric can sometimes be misleading. Using multiple metrics give a fuller picture. The paper also evaluates Marta across 10 different language models, including smaller and large open source models, as well as closed source models like GPT-4o and Claude. So the overall evaluation setup is broad and designed to test both flexibility and reliability. Results on simpler tasks. This slide presents the results on simpler benchmark penguins in a table. The key takeaway is that Marta performs strongly across different model sizes and model types. It is not just tuned for just one specific large model. That is why the paper emphasizes model agnostic behavior. Another important observation here is that more reasoning is not always better. On simpler tasks, if you add too many extra prompts or too many repeated reasoning steps, the performance can actually drop. That is why the slide refers to as over prompting penalty. Marta avoids that problem by not blindly using every reasoning path all the time. Instead, it uses tools like the scheduler and confidence checker to decide when extra work is worth it. So the overall message is of this slide is that easier tasks, Marta stays accurate while also being more disciplined about computation. This slide moves on the harder benchmark, table bench, where the real strength of Marta becomes more visible. The paper shows that Marta performs much better than baseline systems on these more difficult questions. The slide highlights gain of about 40.1% in exact match, 46.7% in fuzzy matching, and 33.1% in F1 compared to sync TQA on the harder setting. These are significant improvements and they support the core claim of the paper. When table reasoning becomes more complex, relying on only one reasoning path is not enough. On harder tasks, different reasoning styles can complement each other. One path may fail while another may succeed. Marta benefits from that diversity and then uses its checking mechanism to select a strong final answer. So, this slide is really the strongest evidence why multi agent designs matter. This slide looks at two important questions. First, which components of Marta actually matter? And second, how much efficiency do they add? On the ablation side, the paper shows that removing the confidence checker hurts performance, especially on exact match. That means that the conference checker is not just a speed optimization, it also improves the decision quality of the framework. On the efficiency side, the results are also strong. The conference checker reduces unnecessary judge agent calls by about 95.8% on simple tasks and 60.6% on complex tasks. The scheduler also reduces the number of initial LLM calls by around 7.6 to 14.6%. So this slide shows that smaller helper modules are not just extra decoration, they are just meaningful components that improve both performance and practical efficiency. No universal, no universal best reasoning path. This slide highlights one of the most important conceptual findings of the paper. There is no single reasoning path that works best all the time. For some questions and models, COT works better because natural language reasoning is enough. For another, POT works better because the problem requires calculations and more structured logic. In other cases, text to SQL is useful because the table can be queried more clearly in a structured form. The best part depends on several things: the type of question, the structure of the table, and the size of the model, and the type of the model being used. So, this slide supports the paper's main design decision. If no single reasoning strategy is universally best, then the reliable framework should not depend on just one. It should it should combine complementary reasoning paths and manage them intelligently, which is exactly what Mata does. This slide gives a more balanced and realistic discussion of the framework. Even though Marta reduces unnecessary calls and uses lightweight tools to save compute, it still depends on full LLM inference for each reasoning path that is executed. So the framework is still not cheap in an absolute sense, especially when large models are used. The slide also points out broader concerns around deployment. A system like this may produce more reliable answers on benchmark, but that does not automatically mean it is safe in high stakes settings. If the underlying model is biased or wrong, the framework can still produce problematic outputs. That is why the slide mentions caution for real world use in areas like healthcare or finance, unless strong safeguards, auditing, and verifications are needed. So, this slide is more important because it reminds us that the benchmark success is valuable, but it is not the same thing as guaranteed safe deployment. To conclude, the paper proposes MATA, a multi-agent framework that for reliable and flexible table question answering. Its main contribution is that it combines three different reasoning paths: COT, POT, and text to SQL, and supports them with lightweight tools like scheduler, conference checker, and format checker. This design helps the system in three ways. It improves reliability by checking across reasoning paths, it improves flexibility by working across different models and question types, and it improves efficiency by avoiding unnecessary expensive calls. The experimental results show that this framework is useful, especially useful for harder table question answer tasks where the reasoning styles is alone not usually enough. So the final message of the paper is that strong table question answering requires more than just powerful base model. It also needs smart coordination between different reasoning methods, plus mechanisms for validation and efficient decision making. Thank you.